We're not going to use what we just learned to solve some problems involving similar figures. So we have our information over here, our different ratios. Remember, the ratio of the lengths is called the scale factor. So we'll see that term some. And let's go ahead. Each pair of figures is similar. Find the scale factor of the figure on the left to the figure on the right, then find the ratio of surface areas and the ratio of volumes. All right, we know that they are similar, so therefore their sides have proportional lengths, which is the scale factor, so we'll go ahead and find that first. You really can use any of the corresponding parts here, and we can even do both values if we wanted to check to make sure we're right. So let's take the smaller numbers here, 30. So the one on the left compared to the one on the right, 30 to 21. So the scale factor is going to be 30 over 21, which does reduce, and we always want to reduce scale factor. We don't want to leave anything as an improper fraction. So 30 to 21 reduces to 10 over 7. So that's our scale factor. Then the ratio of our areas. So this is really the scale factor, or the ratio of the lengths. So the areas is going to be 10 squared to 7 squared. Now, don't just think, oh, I can reduce the squared. You cannot reduce squareds. So 10 times 10 is 100, and 7 times 7 is 49. And then the scale factor, or the ratio of the volumes is going to be, looking over here to volume, it's going to be 10 cubed over 7 cubed. And if you multiply that out, that's going to give you 1,000, which you should know that one, over 7 times 7 times 7 is 343. All right, so there's the answer for that one, and that's how you're going to do the other ones as well. Just realize on number 2 here, you're given the radius for the first one, but the diameter for the second one. So you'll want to find actually what the radius is if you're going to use that length. You could use the 60 and 70. All right, moving on to the next set of questions. The scale factor between two similar figures is given. The surface area and volume of the smaller figure are given. Find the surface area and volume of the larger figure. All right, so we know our scale factor here is 1 to 5, so let's write it as 1 to 5. And so the ratio of areas is going to be 1 squared over 5 squared, which is 1 over 25. Now what we do with that, we take that scale factor, 1 over 25, and we relate it to what we know. Now let me just go back to our directions real quick. The surface area and the volume of the smaller figure are given. So we have our scale factor of areas is going to be related to the surface area, and the surface area that's given is the smaller one. So obviously the 1 is smaller than the 25, so the 15 is going to go on top. And we want to find the surface area of the larger one. Let's just put S here. And then we cross multiply, 1S. So surface area of the larger one is going to be equal to 25 times 15. That is 375. And then it would be centimeters squared. Okay. So let's go ahead and look at the next one, or the next part. So the volume, or the ratio of the volumes is going to be 1 cubed over 5 cubed, which is 1 over 125. And so now we're going to do the same thing we did with volumes. We have 1 over 125, that's our ratio of the volumes, is going to equal the smaller volume over the larger volume, which we don't know. So we'll cross multiply. 1 times V is V equals 30 times 125 is 375. Which makes me go back and realize, well, 375. So we have centimeters cubed. Okay, so that's how you do those types. And moving on to the last group, some information about surface area and volume of two similar solids has been given. Find the missing value. So you notice on the first four, there's a volume missing, and on the second four, there's a surface area missing. So let's go ahead and look at these. So what we want to do as we approach these types of problems, we want to go ahead and make a ratio of the ones that we know. So we know, and what I mean by that, we know both the surface areas here. We don't know both the volumes. So we're going to make a ratio. So 99 over 704. We want that ratio. That's the ratio of our surface areas. And now we want to reduce that if possible. So go ahead and use your calculator to reduce that. And here we go. So it looks like 3 doesn't go into 704, but maybe 11 does. So let's see if we can reduce by 11. 704 divided by 11. Oops. 7. So both of these reduce by 11. So this is going to be 9 over 64. So that is the surface area ratio. We want to find the volume ratio. Well, first we have to actually do one step backward to take 2 steps forward. So we are going to find our scale factor. So realize that this is an x squared over a y squared, or an a squared over a b squared, which we were using earlier. We want to go back. So what we do to find the scale factor, or the ratio of lengths, is we take the square root of this thing. We take the square root because it's squared. So we take the square root of 9 over the square root of 64, and that gives us a scale factor of 3/8. And once we know the scale factor of 3/8, we can use that to find the ratio of volumes. So volume is going to be 3 cubed over 8 cubed. So 3 cubed over is 27, 8 cubed is 512. And that is the ratio of our volumes. Now that we have that, we can use that to help us find the missing volume. So volume, sorry, that's not what we want. We want to take our scale factor, 27 over 512 equals, now this was the smaller one because we had a 99 and a 704, equals 405 over V. And now we're going to cross multiply. So we have 27V equals 512 times 405, 207,360. Divide both sides by 27, and we'll have our volume. So divide that by 27, and volume of the second solid is 7,680 kilometers cubed. All right, so let's just recap that. What we did is we found the ratio of the two values that we knew. So in this case, it was the surface areas. Once we found that ratio, because it was surface areas, and surface areas are the scale factor squared, we took the square root of that to find the square scale factor. Once we knew the scale factor, we cubed it to find the scale factor of the volumes. And once we knew the square scale factor of the volumes, we set up a proportion with that scale factor and used the volume that we knew to help us find the volume we did not know. So number 12, 13, and 14 will be like that one. Let's jump down. Oh, maybe not. Sorry. 9, 10, and 12. Are like that one. And then let's try, let's do 15. So similar idea, except this time we know the volumes. So what we want to do is we want to find the ratio of the volumes. So the ratio is going to be 2,000 over 3,456. Now we want to reduce that. So 2,000, 4 definitely goes into that. So let's reduce by 4 to start with. Maybe even higher numbers go into it. We could play around with a little bit. Let's try 16. All right, that's good. And let's check if 16 goes into 3,000. 3, 4, 5, 6. 3, 4, 5, 6 divided by 16. And that's 216. Okay, so they reduced. Now you might not have guessed 16 first. You might have started with 2 or 4 and worked your way up, but you want to simplify that fraction as much as possible. And what we can do now, that's our ratio of volumes. The scale factor is going to be the cubed root of the ratio of volumes, which is 5 over 6. And then we can find the ratio of surface areas. The ratio of surface areas will be 5 squared over 6 squared, which is 25 over 36. And now we can set up our proportion. 25 over 36 equals the ratio of our surface areas, so 25 or 250 over x. And really this one looks pretty easy because to get from 25 to 250, you multiply by 10. Multiply by 10, so x has to equal 360, and this will be meters squared. You could obviously cross multiply to solve that one too.